topic that the BC class has seen, but the BC class may have forgotten. This is a topic that the AB class did not see. There are a couple of sections in Chapter 9 that deal with some things that have to do with trig identities. They're typically more likely to show up in the multiple choice part of the AP exam. So I'm not super worried about these topics showing up. At the same time, some of these things are actually relatively easy, and as a result, anytime there's a pretty easy fact that you can, just kind of write down on a card somewhere and have in reserve if you need it, it's a good thing to mention. So there's a question on the progress check. I think it's the Unit 6 progress check, where they ask you to take an integral. And by the way, it's a brutally difficult one, okay? I'm not... you still have a whole lot of work to do even once you get to this point. But anyway, if you saw an easier example, what I'm going to show you is pretty simple. So if I ask you to take the integral of a cosine squared of 4x, okay, your gut instinct, if you're not in the BC class, should be, we can't take that integral, okay? The reason being that this is really cosine of 4x squared, okay? The derivative of the inside function is negative 4 sine of 4x. You have to have a sine of x outside of parentheses to be able to be taken away when you reverse the chain rule, and they didn't give you that, okay? So normally you just say, oh, cosine squared, can't take the integral, guess I go into something else. As you know from working with trig expressions, sometimes you can write trig expressions in a different way, and this is an example of one that's actually relatively easy to write. So a couple of trig identities that you may have forgotten, but that do come up from time to time, are the following. These are the cosine double angle formulas. One fact is that the cosine of twice an angle is equal to 2 cosine squared of theta minus 1. Okay? There's a second identity. There are actually 3 different identities that are usually taught for the cosine double angle. One of the other ones is that cosine of twice an angle is equal to 1 minus 2 sine squared of theta. Okay? So whether or not you remember those, you don't need to know that necessarily for what I'm getting ready to show you, but I'm going to give you 2 identities that come out of this. Notice that I could solve this one for cosine squared, and I could solve this one for sine squared, okay? And if I did that, I would add 1 to both sides here, so I would have cosine of 2 theta plus 1 is equal to 2 cosine squared of theta. And then I could divide both sides by 2, and actually I'm going to write the plus 1 over here. Divide both sides by 2. If I divide by 2, that'd be 1/2 plus 1/2 cosine of 2 theta is equal to cosine squared of theta. And then same kind of thing over here. I could solve for sine squared of theta here. I think I'm going to move this to the other side. I'm going to move that to the other side. Let's see. So 2 sine squared of theta would be equal to 1 minus cosine of 2 theta. And then I could divide everything by 2, and I would get 1/2 minus 1/2 cosine of 2 theta is equal to sine squared of theta. Okay? These are the 2 identities that you want. This one right here and that one right here. Okay? Now those are a little sloppy, so let me summarize these a little bit more carefully. The 2 identities you need: sine squared of theta is equal to 1/2 minus 1/2 cosine of 2 theta. Yes, it's a sine, and yes, that's a cosine there. Okay? The cosine squared identity is exactly the same formula, except you have a plus. So it's 1/2 plus 1/2, also cosine of 2 theta. Okay? Here's the big thing. You can replace a sine squared or a cosine squared with these statements. These aren't integrals. You still have to integrate, but you can replace them with those statements, okay? But notice something really important. This angle here is double whatever that angle is. This angle here is double whatever that angle is. So in this particular case, you go, oh, it's a cosine squared. I can't take the integral of that, okay? Well, cosine squared is equal to 1/2 plus 1/2, still going to be cosine, but it's going to be cosine of twice the angle. So if that's a 4x, it would be a cosine of 8x, and then you're taking the integral. And so, of course, the integral of 1/2 is 1/2 x. The integral of this would be, let's see, we need an 8 here. It would be 1/16 sine of 8x plus c would be our final integral. Okay? So not super common, but these will come up from time to time. Let's try one more example here. Let's say that I wanted to take the integral of something like sine squared of 12x dx, something like that, okay? So you could do the sine identity here. That would be 1/2 minus 1/2 cosine, and remember, it's always twice whatever the angle is, so it's cosine of 24x dx. And again, you have to integrate, okay? So it's going to be 1/2 x minus, derivative of the inside function here would be, that should be an x, would be 24. So we're going to have to divide by 24. That would be 1/48 sine of 24x, then plus c. Okay? So again, not something that's super common, but definitely something, if you're going to have a paper with some formulas or some examples on it, maybe a good thing to throw on there. Nice to use for even powers of sine and cosine.